these are a few things that we've done with Salience in the professional services division to try to address some problems that come up that we hear about from our clients. This is not, well, some of it's straightforward Salience configuration, but most of it's a little bit on top of what the base level API gives you in order to try to get your results more in line with your expectations. So one thing that we hear a lot from our customers is that themes are great. We really like themes because they require no configuration whatsoever. They come straight out of the engine, and they find things that you didn't know what you were looking for. So the example in the last presentation of I didn't know that I was looking for the word peanut butter because it really means ecstasy. And so a keyword search engine wouldn't find that for you very easily, but the themes, it pops out. You say peanut butter, peanut butter, peanut butter. You know, something's going on here. However, themes have no relationship across documents inside Salience. Traditionally, Salience is just document-oriented. There is the collections feature in Salience, which tries to roll themes together a little bit, but collections are limited in size. You can't have a 10 terabyte collection of data. So what you get is similar themes do not get related because they appear in different documents, and it's hard to roll them together. So you get things like account manager and sales manager, for instance. And those are the same thing to a human in all probability, but Salience reports them as different themes. And users are often looking for some kind of mental map that they have on the data in terms of the next level of categorization, sort of sales manager and account manager and sales management and all those kinds of things should all sort of roll into the bucket of something like client-account relationships or something like that. And so you have a number of choices. You can go through and manually create a taxonomy where you roll themes together. You can do some sort of keyword search-based thing where, okay, I know that all these things are sort of similar, so I'm going to create a sort of category in those ways. These things tend to be time-consuming. They're a pain to maintain over time. Your data changes over time, and so you don't get all the things that you'd like to. And so we were approached, we've been approached a number of times with clients with suggestions for how they could deal with this. And they wanted to see what they could do to automate this in some way so that they don't have to go through and perform these kinds of manual taxonomy creation and management. So we actually have had two different types of requests, and I'm going to talk about both of those use cases. Both use cases are based on doing something like this. There's a lot of words on this slide, and there's even some math involved. So I'm not going to go into details, especially not at 3 o'clock in the afternoon, or not into the real depths of the details. But essentially, what we're trying to do here is establish some kind of similarity score, relationship score for themes that are brought out of the documents. And we approach this in in two different ways, using Salience features that already exist in the product. So a limitation of this is that it's done on a static data set. So this doesn't run sort of in real time along with your data. You could probably try that, but that's not the approach we took to helping our clients. So the idea would be, I've got 1 million pieces of social media or whatever spanning the last year. Let me go through and try and find relationships between themes, and that probably holds true for the next X number of months. Language changes over time, new expressions occur. You'd probably have to go back and redo this maybe on a semi-regular basis, every 6 months or something like that. The point is that this is automated, and so you have a new set of data, you rerun it, look at the changes, maybe there's some human curation to say, yeah, I like that, I don't like that. This was just a one-off spike, so I'm not interested in feeding that back into the data set. But so what you do essentially is you run Salience over all this stuff, and you pull out themes, maybe you pull out facets if you're doing collections and the data set is small enough to pull out facets and attributes, pull out entities, those kinds of things. And when you've got all of that, you turn those back into a query. And so you've got a category, you've got two different types of queries in Salience. You've got straight up Boolean ones, which are and, or, not, near, and you only find the words you're looking for. But we also have these concept topics, where you might find things that you weren't looking for. So a word like food might return a match for a post that only has the word chicken in it, for instance, because chicken is a type of food. So there's a lot of power in the concept topics, because you will find things that are not directly co-occurring in documents. You might find things that just have this semantic relationship based on our Wikipedia model. The problem with concept topics, though, is they're relatively slow. And if you have a very large data set, it may take you a long time to run these, whereas the Boolean queries perform very, very quickly. And the other thing is the concept topics might return you things that are linguistically unrelated that you might not like. They may stray too far afield. So you'd have to kind of look at the data and run them and see which one you like better, and how much processing power, how much time you have to wait, and so forth. But so what you get back is this whole series of results saying, for this theme, I got back, when I reran this against the data, what you get back from Salience is a scored return for the document. And so you take those that are the most relevant out of the document for this particular query you've run, and you postulate that there's a relationship of some kind here. And the higher the relevant score, then the more relevant those terms become. And so you form a matrix, like what we have here, and there's the word TF, IDF in there. Probably if you're involved in text analytics, most people know this, but term frequency and inverse document frequency. So these are standard sort of search engine metrics to try to figure out how relevant a term was to the query. So the more frequently the term occurs, the less relevant in the overall corpus, the less relevant it is. The word the, if you get a hit on the, it's not very relevant. You're going to hit almost every document. So you get this big matrix of things, and then you calculate matches between the various terms to determine the strength of the relationship. And did it flip now? I think it flipped. All right. So you have a big matrix of scores that says, this one is related to this one, and you can get back and I don't know if this is readable in the back, probably not. But essentially you go through and you say, okay, I've got this theme, and then there's these 6 other things that were related to it in sort of decreasing order. And so you can postulate that theme 1 is related to theme 2 more strongly than it's related to theme 3, and so on and so forth. And what I've got in here is just a sort of a pseudocode algorithm for how you construct the strength of those relationships, and you wind up with this big matrix of relationships. And then when you're running against a new set of documents that you've never seen before, for this particular use case, we're looking for theme rollup. So this is, if I get account manager and I get sales manager, in 2 different documents. Salience didn't relate them, but we will at an application level now, because we've judged that sales manager and account manager are related. And you can then feed that back into Salience as a theme normalization. So you only get back the top level theme. You could use that as an application level decision to say, I'm just going to keep them the same as they come out of, I'm going to keep them different as they come out of Salience, but I'll present them as the same thing to the end user, and they can drill in to see the underlying verbatim if they want. This is just, it just reduces the amount of things that people have to look at, and it increases the frequency count of anything that you're looking at. So I don't know if anybody's paying attention when Brandon was giving his presentation from Angos to the actual numbers. Except for a few really high frequency terms, a lot of documents or a lot of themes did not actually cover a very high percentage of the documents in the total set. A really popular theme might have come out in 3%, 4% of the documents, or something like that. But if you've got sales manager and account manager and CRM and all these other 7 or 8 things, if you add those all up into a single thing, you're going to get bigger, you're just going to get more documents, right, rolled in there. And then all the other things that Salience gives you become more interesting, right? Because now you've got a larger document set to work with. So if I look at the sentiment or the other entities or all those other kinds of things that come out of Salience, you've got a larger sample set to work with, and I think the ancillary products are more interesting. So this is kind of straight roll-up, straight normalization. And the other use case that came to us was bottomless drill down. So this is a customer who was using a visualization inside a BI tool, and everybody likes word clouds, right? As we heard earlier. And that's right, word clouds and pie charts. So they were using a word cloud to represent standard word cloud. The frequency of the term is represented by the size, of the term in the word cloud. And they're saying as well, I click on the on one of the items in the word cloud, account manager, I get back 500 articles, and I've got a few other things there. And when I click on another thing that comes back associated with sales manager, I get very few things. And if you have short content, you generally are not getting more than a couple themes, a couple things out of that short content. So within a very short period of time, you're down to a document set of 1 or 2. And so all the other things that come out of those documents are not very interesting. Maybe you get one entity, one date, something like that. And so what they came to us and asked for was, well, we want our data to be more interactive. We want people to be able to view sort of a more expansive view of the data. And we stayed with the word cloud visualization for this particular project because that's what they had. But I was thinking more in terms of the network graphs that we just saw in the previous presentation, where you would show the connections between these groups of things and allow people to visualize and wander through. So what we did was we took their data set and we did what I just talked about. We used concept queries for this particular one, and we got some very interesting linguistic matches that you would not have known about. This was a tech company, and I don't know how many of you know anything about file systems, but there's a particular type of file system called ZFS, and it's got a bunch of special words associated with it. And we were able to roll together or show relationships between words that you would not have known about, or you would not have known they were related. They didn't co-occur in documents. They weren't linguistically similar in any way, but the fact that the concept matrix knows that a ZFS file system has all these kinds of operations and commands and so forth, we were able to link all those together. So that was an interesting use case for the semantic, for the concept queries. So I'll show you a little, at least I hope I'll show you something. This doesn't seem to, there we go. So the example here is in the word cloud. Say somebody comes here and they've got a box, and they want to type in a query. This is going to be really painful because I have builds. There you go. So say they're looking for web services. They're interested in web services, hot topic. And what you get out here is you get back themes that were extracted from documents that matched web services. And the size of the theme represents the frequency of it. But the other thing we've done is we've filled in the other themes that were related to web services here. And they're colored so that you can see which ones are sort of those that were co-occurring with web services versus those that were related by some kind of semantic relationship. And what happens is, say somebody picks the Red Hat one, and now we expand out, right? And we say, okay, we're looking for web services or all the things that are related to it semantically, and any of the things that are related to Red Hat. And then you get back this new set of themes, which are again color-coded, right? So the furthest ones away from web services now is open sources, the one in blue. Maybe they're interested in recovery catalog for some reason. And again, we're expanding out. And all those additional terms there, the things that we picked up and expanded out as being related things. And now you get a new set of things, again color-coded to show you the connections. And this is why I thought this was better for a connection-style graph, but this was the visualization they had and they wanted to proceed with. But so you've got a lot of information here. You've got the themes themselves, you've got the frequency of them based on the size, and you've got the distance from your original term based on the color. And you notice as you keep clicking on things, you're not reducing the size of your word cloud. You're not sort of focusing in on something here. You're just you're offering up a connection-oriented view of the data. And it keeps going. Maybe we're worried about security. So just a different set of themes, but you can still see the original ones: service protocols, internet protocols, simple applications, development tool, and so forth. Services technology are all there. They're all the web services ones, and they just keep spidering out. All right, so I'm going to pause there for a second. Any questions on that? Okay, maybe it's straightforward. Maybe you're all doing it already. That would be cool. Another thing that comes up is a more advanced entity configuration. So you get entities that contain common words. And you get entities that contain sentiment phrases, and you want to recognize these entities as entities, and Salience is having trouble recognizing them, and maybe you're losing sentiment or not. And the example I'm going to pick on is Best Buy, because that's one that's come up repeatedly from several customers. And so what happens is that out of the box, by default, Salience does not recognize Best Buy reliably as an entity. Entity recognition uses parts of speech, and Best Buy is not tagged as the appropriate parts of speech for entity recognition, and comes out of the engine with a very low confidence score. And unless you really crank your confidence level down, you may miss it entirely, unless there's other clues in the text to tell you that it's really a company. And so there's a series of steps that I'm going to take you through to show you what can happen, or what you can do. And maybe I'll start. I'm going to be brave, and I'm going to try switching views here. So let's go back to my default setup. So I don't know if you guys are familiar with the user data, but it's where your configurations live. And so that's run off the screen a little bit, but I try to make it big for everybody. And the text is, I went to Best Buy looking for a good discount. It was the best buy I have ever made. And so the phrase appears both as an entity, Best Buy, and as a sentiment phrase, lowercase Best Buy. And with things out of the box, the way they stand, we find Best Buy as a company, and it does have a positive sentiment, but if we look at the details here, the score on this is 51%. And if you crank that down that low in the engine, you're probably going to pick up a lot of garbage entities as well. The default setting for the confidence is 60-some%, and we would not have found Best Buy at all. And so a couple things have to happen. First of all, you can override the part of speech tagging in Salience. So here's a sort of demonstration of the entity recognition processing pipeline. We start tokenization. We're talking about it earlier with Chinese, but thankfully this is English, so it's really simple. There's spaces. And then we look at part of speech tagging. And by default, if you notice, best and by come out as plural noun, or sorry, what's JJS again? Superlative adjective, thank you. And there's a file in Salience called glue patterns, and it allows you to override the default pause tagging. And so I've edited, I have a configuration where I've edited that to specify that Best Buy are both proper nouns. And if you do that, then you're going to up the confidence score that comes out of the entity, because now they're proper nouns. That's the sort of thing that are more likely to be companies. But if you still want to be really sure, you can also put your company in a CDL file, Best Buy. So customer defined list, say this is what it is, and I want to always recognize Best Buy as that. And so, oh wow. Now you guys can't see anything. All right, so I'm going to have to spare you the live demo. But trust me, what will happen is that now you get Best Buy, And the phrase, the verbatim that is put in is going to give you two occurrences of the company Best Buy, one for the capitalized Best Buy and one for the lowercase Best Buy. It finds the capitalized Best Buy, and the linker for entity resolution says, aha, here's Best Buy again. And it's going to put them together, and now you have two mentions, and you don't have the sentiment from Best Buy because, or it was from the second one. So one step further is you can actually force your files to be case sensitive, to only match on a case sensitive, on a capitalized one. So there is a file here called score.dat where you can specify those kinds of rules. This is pretty low level, but so you can force it to say entity matching, has to be case sensitive, but only for those entities that I want to be case sensitive. Or you could do it for all of them. But typically, probably you want to do it only for ones that you know are problematic. Because in any kind of social media, people are sort of loose with their capitalization, right? But once you make a case sensitive, you're going to wind up with one example of Best Buy as a company and one example of Best Buy as a sentiment phrase. And the reason that you're never going to recognize the lowercase one now is first, entity recognition is case sensitive, and second, the sentiment, there's a pattern, a part of speech pattern for sentiment phrases as well, and that keeps us from picking up the proper nouns as being sentiment-bearing phrases and forces the lowercase ones to bear sentiment, and you wind up with, hopefully, what you want. And there's a bunch of other little things that you could do along the way, but that's sort of an example of a real problematic case that seems to come up a lot for some of our customers where perhaps it's not screamingly obvious from the documentation all of the steps that you need to take in order to get this to work in all these cases. Anybody have any questions about that? This is not nearly as exciting as killing people.
Threatening to kill people.
Yeah.
Is there any way to use the context of the broader context that the noun Best Buy is preceded by a preposition? I mean, I can't think of a preposition followed by a sentiment.
If you put the prepositions in the entity patterns file,
or just the part of speech.
Yeah.
That, I could, in addition to the out-of-the-box patterns that go into entity recognition, you could additionally say, and when a potential, set of part of speech tags is preceded by a preposition, give a little bit of an increase to the likelihood that it could be an entity. But again, there are cases where those types of rules are the things that we put into the generation of our entity extraction model. So some of those things are already in there. It has to have enough of those.
Force it to be an entity unless you manually enter an actual name into a company file. You're just sort of playing with the knobs and trying to bump up your possibilities. Anything else? All right. So our third case is we get this a lot when we've got new prospects in the door, and I think
very detailed sentiments, sometimes stories, if you remember that cat-mouse story.
But anyways, some of you are resellers, and you
these
have
are just two
in the door, and maybe this
opposite
is applicable to you.
sentiment
But what we
chunks.
get from people is,
And
tell me what I can do with Salience. And then we say, well, Salience does a lot of things, and there's a lot of stuff that comes out the other end, and you have, pause tag text, and you have sentiment tag text, and you have entities, and you have entity tag text, and you've got themes, and themes have sentiment, and themes have summaries, and you get this web of sort of many-to-many relationships. And our response is always, tell me what you're looking for. And they say, well, I don't really know, but just show me what it can do. Show me something cool, right? And we've been we've worked for, in a number of metaphors, right? Let's put everything into a spreadsheet. Let's put it into Excel, and then you can sort of look, right? But you get these many-to-many relationships that are really difficult to visualize in that kind of 2D format, right? You might have a data visualization tool like, Tableau or Angos or, something like that, but, you can't talk directly to, the data because the Salience API is in the middle. So we were trying to come up with a way that we could use something for quick prototyping. You could give to a client, you could say, here's all the output that Salience gives you, and now you can sort of inspect these results over a large set of results, 1 million results or whatever that is, and you can sort of start to draw your conclusions about whether what you're getting out from your data is valuable, and maybe this will be valuable to some of you. And so we had done some relational database work, but it was kind of a pain to set up. There's a lot of relations in Salience, and trying to explain them all to people was a little bit painful. So as an artifact of another project we were working on, we used Hibernate as a way to save the results of the Salience API to a database. And there were some manual modifications that were needed, but the automatic mapping is actually pretty good. And I don't think you can see any of this back there, nor do you really need to. But suffice it to say, once we have the mapping complete, then we can run and we dump the results. We use SQLite. We're big fans of SQLite because it's free and it's portable. You can just email a SQLite database to somebody. Anybody with a SQLite command line utility can now inspect everything that's in the data. And what you get back out is a large series of tables that are linked together that give you all the results from Salience. So you get the text, and you get the themes, and you get the theme sentiments, and you get the this and that and the other thing, and you can begin to draw views and visualizations. If you've got a data visualization tool that understands databases, you can point at it and very quickly draw out some interesting graphs. So for this particular project, once we had this data in the database, it took me 15 minutes in Tableau to create a pretty compelling visualization, which I can't show because it's internal to a customer, but about themes and how they were changing over time and what was important to various user segments and so forth. And so we went one small step further, and we started working on an extension to our demo application. Probably most of you are familiar if you work with our tools at all. We have this little demo where you can bring up and you can see one document at a time kind of thing. But we were pondering the idea, and I'd be I'd be very interested to get feedback from people if it's useful to extend that demo tool or a tool like it, where you can actually point it at a folder of data or an Excel sheet of data or something like that, and run it, and you can pick the various structured columns that might be in your data, like a date, an author name, source of the data, all those kinds of things, whether they're a drone target or not. And have those come out the other end. The relational database is columns of data. They're associated with all the things. And you've got a database there now that you can plug in. You can point a pivot table at it. You can point a data visualization tool at it, whatever it is. But the point is, all of those many-to-many relationships are already done. You don't need to code yourself against the API in order to get some sort of results out relatively quickly for a new data set or a new client. So if that's of interest to anybody, I'd be happy to hear it either now or after after Seth's presentation. And so that's all I had. And anybody got any questions? Yeah.
Sorry, I might have missed this. The Hibernate is
Yeah.
Something open source?
Yeah.
Okay.
So there's a variety of different. Hibernate is just a way of sort of hibernating data, right? Of just saving it to a database, right?
I'm familiar from AWS, right?
Right. Exactly.
Right, okay.
So there's a variety of ways to work with the data. There's Hibernate, which is in .NET. There's Brian, I think you did the actual work, right? There's a couple other flavors of it. Yeah. So it's basically a database persistence layer, and it does a pretty good job of figuring out the relationships, but you got to fill out the final map yourself, and then you can use it from within any code stack you've got. But we were just taking it a step further to try to integrate it into some kind of front end where an untechnical user who's not going to be writing against the Hibernate layer could still get some value out of it. Okay, thanks.